All right, so let's look at number 20. So for number 20, we're doing the possible rational roots. So remember, what you want to do is you want to find all the factors of your constant. That's what we call P. So the factors of 24 are going to be 1 and 24, 2 and 12, 3 and 8, 4 and 6. And it could be like a positive 1 and a negative 24, or a negative 1 and positive 24. So for that reason, we're going to put plus or minus out in front to take care of it being the positive and the negative of every one of those numbers. All right, then we're going to do the same thing with Q. So Q is your leading coefficient. And so we're going to find all the factors of 2. So that's plus or minus 1 and plus or minus 2. So the possible rational roots are going to be your P's over your Q's. Okay, so let's start with 1. I'm going to put all these guys over 1. So that's just going to be 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 8 over 1, 12 over 1, 24 over 1. All right, then I'm going to put all of them over 2. Okay, so this is going to be 1 over 2. 2 over 2 is already here because that's just 1. 3 over 2 is right here. 4 over 2 is already here because that's 2. 6 over 2 is already here because that's 3. 8 over 2 is here because that's 4. 12 over 2 is 6. And then 24 over 2 is 12. So there aren't any other ones to add other than the 1/2 and the 3/2. So those are all of our possibilities. And I could sit here and I could try every single one of those, but that would take forever, and I don't want to do that. So remember, the little shortcut we talked about was graph it on your graphing calculator first. So when I go to y equals and I put in 2x cubed plus 7x squared minus 10x minus 24, I get this graph right here. And so I can immediately see, since I know a solution is the same thing as an x-intercept, I can immediately see that I have a solution at 2, at negative 1.5, and at negative 4. So I'm going to pick any one of those. I like the positive numbers better, so I'm going to pick the positive 2 and do synthetic division with that. So instead of having to try a bunch of them until I find one that works, if I look at the graph, I immediately know which one's going to work. So I'm going to do synthetic division with 2. So again, pull out your coefficients, 2, 7, negative 10, negative 24, and put those across the top. So we'll bring that 2 straight down. 2 times 2 goes in our next column. 7 times 4 combines to be 11. 11 times 2 goes in our next column. Negative 10 and 22 combine to be 12. 12 times 2 goes in our next column, and that combines to be 0. And it should be 0 because remember that if it's 0, that means that it's a factor, it's a solution, it's a root, it's a 0 of the function. And that's what we got by looking at our graph as well. So since we got a remainder of 0, that means what I was dividing by, x minus 2, is a factor. So remember, x equals 2 is what it looks like as a solution. X minus 2 is what it looks like as a factor. And so I've just taken this cubic equation, and if I write its factorization, I divided it by x minus 2, and when I did, I got this answer right here, 2x squared plus 11x plus 12. All right, so now I'm going to go ahead and factor this guy. Now, if you get here and you don't want to factor, remember, you have your graphing calculator, you can just use the quadratic program. So if you did the quadratic program and you put in 2, 11, 12, it would just automatically shoot out your answers of negative 3/2 and negative 4. But I did go ahead and factor this one, and then I set each one of my factors equal to 0, and then I got my 3 solutions of 2, negative 3/2, and negative 4. Watch out, because probably the most common mistake I see here is you forget that 2 was one of your solutions that you used in your synthetic division over here. So be sure to include that as one of your answers. All right, then let's look at 21. So 21, we're going to do the exact same thing. So we're going to find all the factors of our constant, which is plus or minus 1, and all the factors of our leading coefficient, which is plus or minus 1, and we're going to put P over Q. So that's going to give us 1 over 1 or just 1. All right, so we're going to use that shortcut again. Instead of trying all of our possibilities, I'm going to take this cubic and put it into y equals in my calculator and graph it, and this is what my graph looks like. So since I know that solution equals solution equals x-intercept, then I know that negative 1 is going to be a solution. And so that's what I want to start with on my synthetic division. All right, so again, we're going to pull our coefficients out, 1, 1, 1, and 1 across the top here. So bring the first one straight down, and then 1 times -1 is -1. Combine those to get 0. 0 times -1 is 0. Combine those to get 1. 1 times -1 is -1. Combine those to get 0. So since I got a remainder of 0, I know that what I was dividing by, x plus 1, is a factor. Again, x equals -1 is its solution form. Its factor form is just the opposite of that, or set it equal to 0 to get its factor form. So I know that when I take this cubic equation right here and I divide it by x plus 1, that x plus 1 is a factor because I got a remainder of 0. All right, then let's see what this is going to be. Remember, this first term is always going to be 1 less than what you started with. So I started with a degree of 3. So that means that this is going to be 1x squared plus 0x plus 1, and then there's our remainder of 0. So the factorization then for that cubic is what I was dividing by times the answer that I got. So the answer that I got was 1x squared plus 1. All right, so now I want to see if I can factor that down further. And so I'm going to set each of these factors equal to 0. And so over here, I'm going to get x equals -1. Over here, subtract 1 from both sides, and then to get rid of the square, we're going to insert a square root. Don't forget to put in your plus or minus. And so the square root of -1 is I. Will get x equals plus or minus I. So my three solutions would be -1, positive I, and negative I, because I should get 3 answers since it's a degree of 3. And that's why we only got 1 x-intercept, even though it was a degree of 3, because only one of our answers is real. The other 2 answers are imaginary. All right, then the last one, number 22, we're talking about Descartes' rule of signs. So if we look at the original problem and we count the number of sign changes, you can see positive to negative, there's 1. Negative to negative is not a change. Negative to positive, there's another one, so that's 2. So we have 2 sign changes. So that means that we're going to have 2 positive real roots, or subtract 2 from that, it could also be 0. If I had gotten 3, I would have subtracted 1 and said it could be 3 or 1. If I had gotten 4, I would have subtracted 2 and said it could have been 4 or 2 or 0. If I had gotten 5, it would have been 5 or 3 or 1. So every time you just subtract 2. So that means that I could get 2 or 0 positive real solutions. All right, then to find the negative real solutions, I put a negative x in the place of x in the function. So that's going to be a negative x cubed, a negative x squared, a negative x in the place of x. Okay, so negative times negative times negative is negative, so negative x cubed. A negative squared is positive, so that's going to be a positive x squared times the -2. And then negative 16 times negative x is positive 16x, and then our plus 32. So we could combine this negative 2x squared right here, and then we can see negative to negative, that's no change. Negative to positive, there's 1 sign change. Positive to positive, nope. So I only had 1 sign change. So that means that there could be 1 negative real solution.